Hey guys, hope everybody's doing okay. I want to give you some help on this homework problem, which is the last one in the homework set. It involves KSP, but it's not exactly like something we've done before, but we can figure it out based on what we know about KSP. So the question says you're mixing together some silver nitrate and potassium chromate. You want to know if a precipitate will form. A precipitate is going to form, precipitate is an insoluble solid. But remember, back when we did the KSP lesson, on the lesson on solubility product, even something that is considered insoluble does dissolve a tiny, tiny, tiny bit. So basically what this question is asking you is, do you have enough ions, enough ions present there in solution to have that tiny bit dissolve and the rest stay together in the undissociated form as a solid precipitate? Or do you create such a small amount of ions in this problem that the compound will dissolve, create your ions in solution, and not have enough to precipitate out? Okay, so we want to make sure we figure out how to do a problem similar to this, so we can successfully do it on a quiz or test if one pops up. So the first thing you should do, start with the balanced chemical reaction, right? So I need to know what my precipitate is here. So let's do that. So we have silver nitrate, aqueous, plus potassium chromate, K2Cr O4, aqueous, yields double replacement reaction. So we have silver chromate, so that's Ag2CrO4, and potassium nitrate. Okay? Think back to your solubility rules. So solubility rules, anything that is in group 1 is soluble, or nitrates are always soluble. So this is an aqueous right here. I ran out of room there, AQ. All right. And there we go. And the Ag2CrO4 has to be your precipitate, so that is your solid. All right, balance the equation. You have 2 here, 2 here, and then leave the K2CrO4 and the Ag2CrO4 alone. So your precipitate here would be the silver chromate. Okay, anytime we're dealing with a precipitate, insoluble solid, we need to write, and we want to know if we have enough ions to even create that. We want to take this out. All right, let's isolate that and write a dissociation equation for silver chromate. All right, so it's going to look like this. We wrote them back in the KSP lesson. All right, so Ag2CrO4 solid produces 2 Ag ions and 1 CrO4 -2 ion. All right, this is what we're going to focus on right here. Okay, so here's our solid precipitate that we want to make in our overall equation, and it dissociates into these ions in solution. All right, so will this equation here, will this equilibrium system lie to the left with your precipitate, or will it lie to the right? Okay, the only way to figure out where this is going to lie is if you figure out where where is this system here? Is it at equilibrium? Am I am I shifted to the left? Am I shifted to the right? The only way to figure that out is look at your current conditions, all right, and figure out how they compare to the KSP for silver chromate. All right, so the KSP for silver chromate is 9 times 10 to the negative 12. Look at these values up here, and we can do something with them to figure out if we're at equilibrium or not. All right, and if we are not at equilibrium, which way will it shift? To the left or to the right? So I need to figure out my Q value. All right, so Q is the same as KSP or KC or whatever. It's concentration of product, so it's Ag squared times chromate, CrO4, -2. All right, my reactant is a solid. I don't include it here. All right, so what I need to do is figure out my concentration of silver ion from up here and my concentration of chromate ion. Now, the thing is, you took 0.2 liters of silver nitrate, 0.05 liters of potassium chromate, and mixed them together. So this is not as easy as you saying, oh, I have 0.060 molar silver. Let me write it in here. Oh, I have 0.10 molar potassium chromate. So chromate. Let me just add that, like plop that in there. I can't do that. What you did was you added 0.2 liters of this, 0.05 liters of this. Those volumes are additive, right? So you create, like you diluted both of these. So what you want to do is find your new volume. Okay, so the new volume is equal to your 0.2 liters and your 0.05 of the potassium chromate. So it's 0.250 liters. Okay, now we want to find our new concentrations as well. Okay, because they're not 0.06, they're not 0.10. So how do we do that? Well, we diluted both of these solutions by mixing them together. So all you have to use is your dilution formula. So let's do that for the silver nitrate and for the potassium chromate. Okay, so silver nitrate is AgNO3. All right. So you have one silver ion in your compound. So it makes this easy to do here. So you have, we'll do silver first. You guys know how to do this from Chem 1. So we have M1V1 equals M2V2. All right. Your M1 for your silver ion was 0.060. Okay, your V1 was 0.200 liters. That equals M2 times V2, which we said was right here, our new volume, 0.250 liters. Okay, solve, and you get your M2 for your silver ion equal to 0.048 molar Ag+. Okay, you want to do the same thing. Okay, I ran out of room here. You want to do the same thing for chromate. All right. So if you take a look at what we have here, your initial molarity was 0.010 molar of your potassium chromate. There's only one chromate ion here, right? So that's the molarity of potassium chromate of 0.010 molar is the initial molarity of your chromate ion. Okay. So I'll do it here real quick, just underneath. So for chromate, M1V1 equals M2V2. M1 we said was 0.010 molar. V1 0.050 liters equals M2. And your V2, we already said up here, our new volume was 0.250 liters. These are all going into the same flask or container, right? So that's why our new volume is additive of our two volumes that we started with. So we solve for it, you get M2 equals 0.002 molar. CrO4 -2. Okay? So now, all we need to do, this is super easy now, what we need to do is we found our new molarities of silver and chromate. All we have to do is plug them into our Q expression. All right? So to find Q, we have our concentration of silver. We said our new concentration was 0.048 molar. Our new molarity of chromate was 0.002 molar. Okay, solve, and you get a Q value of, now it's 0.048 squared, right, times 0.002. You get 4.6 times 10 to the -6th power. All right? So now, all you need to ask yourself is, how does Q compare to KEQ, or KSP in this case? KSP is to the negative 12th power, Q is to the negative 6th. So clearly Q is greater, way greater than KSP. All right, what's that mean? So we're using this equation right here. All right, so this reaction occurs, right? I want to create this solid precipitate right here. I need to figure out, are there enough ions in solution to make it saturated so this actually is formed, okay? If the concentration of silver and chromate was really small, they would stay dissolved and no solid would be formed, right? But what we want to do is see if this solid will be formed. That only is going to occur if we have too many of these ions right here, all right? So Q is way larger than KSP, and that's looking at this equation here. So if Q is greater than KSP, that means your products, okay, are way bigger than they should be, right? So if Q is greater than KSP, from the previous lesson on reaction quotient, reaction will proceed right to left. Okay, it will go backwards. Okay, it will proceed in the reactant direction in order to establish equilibrium, right? The only way to make Q smaller, which we clearly need to make it smaller, because look how much bigger it is than KSP. The only way to make Q smaller is to take these values here and make them smaller, right? So you have to get your silver ion concentration and your chromate ion concentration smaller. There's too much of it floating around in that beaker. It needs to go back to the left, okay, reform, okay, or form silver chromate solid. So it takes the ions out of solution, decreases their concentration, so we end up with a KSP value of 9 times 10 to the negative 12. All right? Since the reaction proceeds right to left creates your silver chromate precipitate. Okay? So, will any precipitate form? Yes, obviously, after all that. Okay? Big, long explanation here for how to do this. It doesn't take this long once you get the hang of it. All right? But this is really showing understanding of KSP and solubility and reaction quotient Q. All right. So start with your overall equation, isolate your precipitate, and look at the equation that's occurring for that. Okay, your precipitate equation is this, right? Your KSP setup. Figure out your concentrations of silver and chromate ions in solution from the data given to you. All right. In this case, it's a new solution being created, which is why your new molarity was 0.048 molar silver and 0.002 molar chromate. Plug them in, solve for Q, see how it compares to KSP. See how your reaction will shift. To wrap it all up, if Q was really small, if these values were really tiny, and Q was less than KSP, the reaction would shift in the forward direction, creating ions, right? And not having your precipitate, okay? Because it would be shifting to the right, which is dissolving. All right, so that's how you want to figure out all of that. If you have any questions, we can talk about it, but that kind of wraps up, the last practice problem here. You guys should be pretty good with the other ones. If not, just make sure you let me know. All right, thanks, guys.